Hi guys, so this quick video will outline two kind of uncommon topics, but it's still important that we go through them so that there are no surprises in the exam, right? So the topics here will be energy, like kinetic and potential energy and conservation of energy, as well as hydrostatics, which is simply just pressure underwater, okay? So first off, energy can be defined as the capacity to do work, and the SI unit, as we all know, is the joule or J, right? There are many different types of energy. Some of the common ones that you would know are electrical, chemical, light, heat. But in this table, they ask for some kind of uncommon ones, right? So in radioactivity, you would have heard the words ionizing radiation. That ionizing radiation is in the form of energy, right? And in terms of waves, we have electromagnetic radiation. And finally, well, this one is an easy one. Objects in motion, they have kinetic energy, as opposed to objects that are static or in one place, they have potential energy. Okay, so here is a conversion question. So state the main energy conversions taking place when a flashlight is turned on. So assuming that is a battery-powered flashlight, when you turn it on, the chemicals in the battery will have to generate an electrical signal, and this will then turn on the bulb, which is the light. And finally, flashlights get hot, right? Everything gets hot when energy is being converted. So we have chemical in the battery, electrical from the battery to the bulb. The bulb has the light energy as well as it emits heat energy. So these are the energy conversions taking place. Okay, so this is a kind of by the way part in this question here where we have to mix and match the units to the quantities, right? So it's a good practice for your formulae. So density, we know this mass per unit volume, which is essentially mass over volume. So mass will be in kilograms, volume will be meters cube, right? Moment, that's the force multiplied by the perpendicular distance. So you have Newton meter, and finally, well, the last one will be linear momentum. But here we have the definitions for some of the forms of energy. So kinetic energy could be defined as energy that a body possesses by virtue of its motion. Potential is the opposite, energy that a body possesses by virtue of its position. And finally, we have one of the important formulae you need to learn here. This is the potential energy formula, which is E for energy is equal to mass multiplied by gravity multiplied by h, which is the height or the change in height, right? So the change in potential energy will change depending on how high an object is, and we'll have some calculations of this coming up. Finally, we have another energy conversion here in a waterfall. So at the top of a waterfall, the water here has gravitational potential energy. Now the water is going to fall down the waterfall. So here it will have kinetic energy. And that is the main change. Now we don't know what happens at the end of the waterfall. Some waterfalls fall into a pool, so therefore it will go back to potential energy. And some waterfalls keep falling down, so it will keep being kinetic, right? So we don't necessarily have to say what happens after it changes to kinetic, because we don't know. Okay, here we have an example of a pendulum. So in a pendulum, it starts to swing, and you will notice in your lab that when the pendulum swings to the extreme left or the extreme right, it will tend to stop, right? So this is where it starts to slow down to a stop at A, and then it will start to pick up back speed. B is where it has its maximum speed, and then it will go all the way to the right again at C, where it will stop, right? So at A and C, this is the maximum potential energy. And at B, this is where it will be swinging the fastest. This is the maximum kinetic energy, right? At B. So that's what I just described here, right? Another point D is between A and B, right? So if the pendulum is returning to A to complete an oscillation, explain which type of energy is increasing and why, right? So look at the direction of D, right? Here the pendulum was picking up speed at B, and now it's going to A, and we know already that it's slowing down, right? So therefore, kinetic energy is being converted to potential energy because it's being slowed down, okay? And here we have a calculation. So netball is a popular sport played across the Caribbean. If a netball has a mass of 0.1 kilograms and a velocity of 5 meters per second, calculate its kinetic energy. So this is the second formula that we have to know. Is E, K for kinetic, is equal to a half mv squared. Right, so m is mass, v is velocity. Very simple, right? So a half multiplied by the mass, which is 0.4, multiplied by 5 squared. So you simply put this in your calculator and we will see what we get. A half by 0.4, and I get 5 joules. All right. Okay, so the law of conservation of energy, very important to know. Energy cannot be created nor destroyed. It could only be converted from one form to the other. And here is a very nice question that tests that definition out, right? So a goalkeeper drops a football of mass 0.43 kilograms vertically downwards from rest. So he's holding it, right? And then he's just dropping it on the ground. Calculate the velocity of the ball as it makes contact with the ground. Now you might think, if they didn't ask about energy here, you might think, oh, there's a kinematics question. You could use one of them fancy questions like the s squared is equal to u squared plus a half whatever. No, you can't, right? Because we don't have enough information, right? And furthermore, where in kinematics did they ever give you the mass of an object? So that alone, and the fact that they had energy before, means that you have to use one of your energy formula or both of them, right? So let's see what information we have here, right? So we have the mass, we have the height. So you're already thinking, just looking like it here, the potential energy formula. Cool, because we have G is 10, right? Look, they have it here. We have G, we have everything here. But they want to know what is the velocity of the ball, and where in that formula is velocity? Nowhere to be found. So you look back into your energy formula and you say, oh wait, but the kinetic energy is has V in it, but we don't know the energy and we don't know the V. So they don't have one unknown, they have two unknowns, so we can't use that formula. So what are we going to do? Well, we have the mass, the gravity, and the height. So we could actually figure out this E here, which is the potential energy. And from the law of conservation of energy, energy cannot be created nor destroyed. It could only be converted from one form to the other. So as the ball is being dropped, it is actually just being converted from potential to kinetic. So whatever the E is here in the potential, it's going to be the same E for the kinetic. So therefore, we calculate the E potential energy first, and we use that for the kinetic formula, and we will find our V. So let's put these values in. So 0.43 multiplied by 10 multiplied by 1.5, and that is going to give us, 6.45 joules. So now I could put in the 6.45 here is equal to a half, and the mass is 0.43, and we have V squared. So first, let's get all of those things across the left-hand side and leave V squared as the subject of the formula, right? So I could work out a half multiplied by 0.43 first. That is not a big deal. That'll make things a little easier. Alright, so I get 6.45 is equal to 0.215 V squared. And I'm simply dividing by 0.215 now to leave V squared alone. So it's going to be 6.45 divided by 0.215. Okay, so that's 6.45 divided by 0.215 is equal to the V squared. And when I put that in my calculator, I'm getting V squared is 30. But we're not done yet. We have V squared here. They want to know what is the velocity. So simply, to find V, we just take the square root of the 30, and see if I could pull up that here. That is 5.48 meters per second. Alright, that would be the velocity of the ball. So this is how we could use both formulae to find out the answer. And this is good practice for your formulae as well. Alright, this was just a by the way force question here, which is to define the term force in case you forget. There's a push or a pull on a body that causes it to change its velocity or its direction, right? Okay, so the last thing is the hydrostatics, which I said is just one formula you need to know, which is to calculate the pressure in water, right? So this diver is under the water, so we want to know what is the pressure of this water here pushing down on him. Well, he is 20 meters below the surface, and we have gravity pushing down on him as well. Right, and also we have the density of the water. You know, water has density, right? So therefore our formula here to calculate pressure is equal to the density of water, that is rho by the way, not a p, multiplied by the gravity multiplied by the height of the water he is under, or the depth, right? So to calculate the pressure the diver is subjected to, did they give us density? That is the density we are using there, right? 1025. So it's 1025 multiplied by 10 multiplied by 20. Let's see what we will get. And we get 205,000. You could put pascals as your SI unit there, right? And there you have it. That's all you really need to know about these two topics. Okay, so I hope you guys enjoyed those topics.